Okay, in this lesson, we're simply throwing together our last few lessons, and we're going to review them. Logarithmic and exponential equations. We're going to solve a few of them again, just to remind you on how to do these. First up, 1 to 1. Anytime you have a log equal to a log, and they have the same basis. Again, all you have to do on these is set your arguments equal to each other. You have x plus 13 is equal to 3 minus x. Get all your x's to one side, everything else to the other side gives you 2x is negative 10, so x must be a negative 5. The only thing you have to check is when you plug it back in, is negative 5 an okay answer? And it is. You do have to condense your logarithms before you do this, so this will be log base 2 of n squared plus 13. On the right side, you have a log plus a log. You can condense that using your power rule. That'll give you log base 2, and I'm going to FOIL this out. That's going to be n squared plus 2n minus 3. Now that you have a logarithm equal to a logarithm, your 1-to-1 rule says now you can set the arguments equal. N squared plus 13 is n squared plus 2n minus 3. Now this looks quadratic. However, when you move your n squared over, they cancel each other out and gives you 13 is 2n minus 3. Move your 3 over, divide by 2, you get n is equal to 8. And again, you can plug that in, but it does check out. Number 3. More of the same. Step number 1, though, you do have to condense. Any coefficients also must be moved up to powers. That'd be a plus 3 to the second using your power rule. On the right side, we're going to raise the 16 to the 1/4 power. And that's going to give me, let's say, 16 to the 1/4. That's the 4th root of 16, which is 2. So we have now the natural log of 2 plus the natural log of a plus 7. And those can be combined using your product rule. So that'd be now the natural log of a plus 3 to the second equals the natural log of 2a plus 14. Now you have, again, a natural log equal to a natural log, so you're going to set the arguments equal to each other. And since I see that it is quadratic, I'm going to go ahead and FOIL this out as I do that. So that's a squared plus 6a plus 9. If you don't remember the shortcut for squaring a binomial, square this, multiply them and double them, and then square this. And you've got that. So equals 2a plus 14. Quadratic, move everything over. A squared plus, when you subtract 2, gives you 4a. Subtract 14 gives you a negative 5. Factor it. A times itself adds multiplies would be a positive 5 and a negative 1. So therefore, you get a is either negative 5 or a is equal to 1. Make sure that they're both fine. When you plug in negative 5 here, though, negative 5 plus 3 gives you a negative 2. You cannot take the log of a negative, so we're going to have to throw that one out. The other one does work. Number 4. Again, we're going to condense our logarithms. A log minus a log, we're using our quotient rule. That'd be the log of 3c plus 4 over c minus 6. Now, right there, you could check. Sometimes that might factor and reduce. It doesn't here. So it's equal to the log of c plus 6. Now that you have log equals a log, you can set the arguments equal to each other. 3c plus 4 over c minus 6 equals c plus 6. We're going to move over this division by multiplying. And luckily, when you multiply, you actually have conjugates over there. So that's very easy to multiply. So you have 3c plus 4 equals c squared minus 36. It is quadratic. Let's move everything to the same side. Let's move it to the right since c squared is positive. So move your 3c by subtracting 3c. Move plus 4 by subtracting 4. So it gives you negative 40. Factor. C times itself is c squared, adds multiplies, negative 8, positive 5. Set them each equal to 0, and that gives you that either c is equal to 8 or c is equal to negative 5. Check them. When you plug in negative 5, I know this. Negative 5 minus 6 gives you negative 11. We're going to have to throw that one out. You can't take the log of a negative. However, when you plug in 8, everything does check out fine. Number 5. Always on these, always isolate your logarithms first. You only have the single logarithm, so move everything to the other side. Gives you log base 2 of 5v plus 23. When you move minus 9 by adding, gives you equals 7. Next step, you're going to change forms. 2 to the 7th is equal to 5v plus 23. And then you're going to solve the basic linear equation. 2 to the 7th power is 128 equals 5v plus 23. Let's subtract the 23, gives you 105 is equal to 5v, so v must be 21. And you do need to check that to make sure that you're not taking the log of negative there or 0, but you are fine. Next one, we do have to condense the logarithms first. So we have a subtraction, so we're going to use our quotient rule. That'd be log base 16 of p plus 5 over p minus 2 equals 1/2. Once you have them condensed, you don't have a log equals those logs, so we're going to rewrite it in exponential form. That'll be 16 to the 1/2 power equals p plus 5 over p minus 2. 16 to the 1/2 is the same thing as the square root of 16, so let's go ahead and rewrite that as 4. Let's move our denominator by multiplying. Make sure you distribute when you multiply. That'd be 4p minus 8 equals p plus 5. Move your p's to one side. Move your numbers to the other side. Divide by the 3, and you have a final answer of p equals 13/3. You can check that. It does check out. Number 7. Again, step number 1, let's condense. Let's go ahead and raise this to the 3rd power, and that'd be 2 to the 3rd, which is 8. So you have a natural log plus a natural log, so we're going to combine those by multiplying. That'd be the natural log of 8 times r plus 1 would be 8r plus 8 equals 7. Rewrite it in exponential form. The base here is e, so we're going to do e to the 7th power is equal to 8r plus 8. And from here, if you want to leave it exact, let's go ahead and move the plus 8 by doing minus 8. And multiplication by r, let's divide by 8. Or multiplying by 8, let's divide by 8. And there's your exact answer. Type that in to get an approximate answer, and you'll get about 136.08. There's your two answers. Number 8, let's move our coefficients up top like that. 64 to the 1/3 power, that's the cube root of 64, which is 4. So we now have, you can scribble that whole thing out, that's 4. Log base 9 of 4 plus log base 9 of n squared. We can combine those using our product rule. That'll be log base 9 of 4 times n squared equals 2. Now it's pretty simple. Rewrite it in exponential form. 9 to the 2nd power is equal to the argument, which is 4n squared. Since you're missing an n term, you can just simply divide by the 4. N squared is 81 over 4, so therefore n would be plus and minus the square root of 81 over 4. Square at the top, square at the bottom, and you get plus or minus 9/2. Number 9, now we're solving some exponential equations. Now the simplest way to solve them is, in this case, if they're 27 and 9, if they have the same bases, you can rewrite them. 27 I know is 3 to the 3rd, so 1 over 27 would be 3 to the negative 3rd. So let's write that like this. 9 is 3 to the 2nd. Let's rewrite it like that. Power to power, let's multiply. That would be 3 to the negative 6x plus 18 equals 3 to the 2x minus 2. Now that the bases are the same, you can simply set the exponents equal to each other. Solve that, gives you 8x equals 20. So therefore, divide by 8. Divide top and bottom by 4 to reduce it, and that gives you a 5/2. So x is equal to 5/2. Next up, number 10. All of these are base 2 numbers. So 4 we can write as 2 squared. 8 is 2 to the 3rd, so 1 over 8 would be 2 to the negative 3rd. And then 32 is 2 to the 5th power, so we're going to write it like that. Powers to power, now let's multiply over our exponents. That's 2 to the 6m plus 2 equals 2 to the negative 3m minus 12 times 2 to the 5m minus 10. Let's combine these because we need to condense as much as we can. So it'd be 2 to the 6m plus 2 equals, when you're multiplying two bases, like bases, you add your exponents. So that'd be 2 to the combined like terms. That'd be 2m's when you combine these, and then negative 12 and negative 10 would be negative 22. Since the bases are now the same, let's set our exponents equal to each other. 6m plus 2 equals 2m minus 22. Move all your m's to the same side, gives you 4m equals, move the 2 by subtracting, that'd be negative 24. So m would be negative 6. Number 11. Now here, we can't change both of these to where the bases are the same, so we're going to have to solve this with logarithms. You can do one of two things. You can either take the logarithm of both sides, or remember, I'm a big fan of just simply change forms. This would be log base 5 of 90 equals w minus 1. Rewrite that as the log of 90, your change of base formula, over log of 5, so you can type it into your calculator, equals w minus 1. Then simply move minus 1 over by adding 1. That's the exact answer, or you can type it into your calculator and you're going to get approximately 3.7959. Number 12. Step number 1, go ahead and move that 16 over by adding. That'd be 136. We have e to a power equals 136, so let's simply change forms there. That'd be log base e, which we can write as ln, of 136 is equal to 3r minus 2. If you want the exact form, now let me show you something. You got to move minus 2 over by adding 2. You got to be careful if you're going to write it like this, 136 plus 2. Make sure that you understand that the 136 is what you're taking the natural log of. So you could either put those in parentheses, or another solution, if you want to put the 2 out front, then it makes it more obvious as well. Then you're going to divide by the 3, so there's your exact answer. Or when you type that in, 2 plus log, natural log 136 divided by 3, you get approximately 2.3042. Number 13. Again, we always have to start out by isolating our exponential. So let's subtract 14. That gives me negative 8. Divide that by the negative 4, and that gives me 2. So I now have 9 to the 2k plus 5 power equals positive 2. Let's change forms. So it'll be log base 9 of 2 is equal to 2k plus 5. We could change forms, change a base. That'd be log of 2 divided by the log of 9 equals 2k plus 5. And we can type that into our calculator. Or if you would like to, you could subtract 5 and divide both terms by 2, or multiply both terms by 1/2. It's the same thing. I'm going to type it into my calculator and go ahead and get my approximate value for k. Again, type this in, subtract 5, divide by 2, and you get k as approximately negative 2.3423. Number 14, isolate your exponential by adding 9. To get rid of the 2/3, let's multiply by the reciprocal. Let's cross cancel. That's a 1 and 15. That gives me 45. So our new equation is 5 to the m minus 8 is equal to 45. Let's rewrite that. And again, I'll show you the other method. You can rewrite it, or you can take the log of both sides. That'd be the log of 5 to a power. Let me leave some space there. The log of 5 to a power, and that power you're actually going to bring down front anyway, so I'm going to go ahead and bring it down front, equals log of 45. So log both sides, bring the exponent down front. Move the log of 5 by dividing. And you're going to end up with the exact same thing either way. So now you have m minus 8 equals that. I'm going to go ahead and erase this and just put m minus 8. And then last step, you just move minus 8 by adding 8. So m is equal to, this is the exact answer. Typing it into your calculator gives you approximately 10.3652. Number 15. Now on these, I definitely want you to just take the log of both sides. That'd be the log of 3 to a power equals the log of 8 to a power. The powers can be moved down front. Make sure you put them in parentheses. So x minus 5, move down front, put it in parentheses. Distribute. That'd be 4x times log of 3 plus 1 times log of 3 equals x times log of 8 minus 5 times log of 8. Move all your x terms to the same side, so you have 4x log 3 already over here. Let's move our x log 8 by doing minus x times log 8. Move all your other terms to the other side. So the log 3, I'm going to move over here by doing minus log 3, and you already had the minus 5 log 8 over there. Next step, factor out your x. You're left with a 4 and a log 3 minus just the log 8 equals the negative log 3 minus 5 log 8. Last step is, since this is being multiplied by x, we're now going to move it to the other side by dividing. So you're going to divide by 4 log 3 minus log 8. So this is your exact answer. All those numbers out front can be moved up into exponents. That's going to be approximately negative 4.9658. And number 16. 4 to a power equals 7 to a power, so let's take the log of both sides. That'd be the log of 4 to a power, and I'm going to go ahead and move that power down front just to save myself a step, equals the log of 7 to a power, and go ahead and move that power down front as well. Distributive property gives you 2x log 4 plus 3 times log 4. And again, you could move the 3 up to an exponent if you want. Equals 15 log 7 minus 2x log 7. All the x values get moved to the same side, so you have 2x log 4. Move the minus 2x log 7 by doing plus 2x log 7. Leave the 15 log 7 over here, and let's go ahead and move this 3 log 4 by doing minus 3 log 4. Factor out the x. You're left with a 2 log 4, which again could be written as log 16, plus 2 log 7, which could be written as the log of 49, equals 15 log 7 minus 3 log 4. Last step, since this is being multiplied by x, we are now going to divide by it. So divided by 2 log 4 minus 2 log 7. Mark that out. So this is what x is equal to. And again, all the coefficients can be moved up to the exponents, and that's going to be approximately 3.7557.